talk is called Don't Get Distracted. I'm going to hit the ground running in a few minutes with some potentially disturbing content, which will include descriptions of, references to, but not descriptions of killing and suicide. So if that's not your thing, feel free to take the next couple minutes while I introduce myself to find another talk. No one will mind if you scoot out, even if you're in the middle of the row. Yes, I know that these slides are blank. No, they are not broken. I've been a developer for about 10 years. I have a bachelor's degree in software engineering. I've worked in software jobs in all sorts of industries, including most recently at a consulting company where I worked with many businesses varying needs. I've built tools from a social support network for people with type 1 diabetes to rate comparison services to it's okay. To a platform for building solar installations. I've even worked in task management software for banks. There are no slides. Now I work in Heroku at the support team, and I help developers like yourselves with some pretty interesting problems shipping your code to our platform. I also work on the Ruby task force, where I help maintain the tools that turn code into running applications. In the past 4 years, I've organized Keep Ruby Weird, a community-oriented conference in Austin, Texas. I'm going to tell you about how I took a job building software to kill people. But don't get distracted by that. I didn't know it at the time. Even before I walked across the stage for graduation, I had accepted an offer for an internship. It paid twice what I had been paid at my highest paying job to that point, and I'd spent years in college with low paid or working for free. I'd be joining a contracting company for the Department of Defense, which is the part of the United States government that is the military. The DoD outsources all sorts of things, from P-8A multi-mission maritime aircraft to blue Shade 451 poly wool cloth. They also outsource a lot of software projects. At the time, I thought nothing of the fact that I'd be working for the military. They're the good guys, right? My dad was in the military, and so was my grandfather. I have great respect for those in the military. It was good money, a great opportunity, and a good friend of mine had gotten me the gig. Life was good. I showed up for my first day of work in North Virginia, or NOVA as the industry likes to call it. I met the team and I learned what we would be working on, a tool to find Wi-Fi hotspots using phones. It seemed pretty cool compared to what I'd built up to that point. The most complicated thing I'd created was an inventory management system. That app didn't concern itself over much with persistence or databases. It was all there in memory, and if it forgot how many Aerosmith CDs you had, who cares? Honestly, the idea of locating Wi-Fi hotspots based on where the Wi-Fi signal strength as your phone moved around was pretty intimidating to me. I was impressed by the idea. But don't get distracted by all this. The software was intended to kill people. I joined the team after I'd already gotten started on the project. The gist of the tool was that we would look at how a Wi-Fi signal strength changed as you moved around. Generally speaking, if you're moving around and the signal strength gets stronger, then you're probably moving closer, and if it gets weaker, you're probably moving further away. To find the Wi-Fi hotspots, we'd collect two pieces of information: the signal strength of the Wi-Fi signals and the location of your phone. To predict the actual location of the Wi-Fi signal, we used a convolution of two algorithms. The first is R-squared. It measures the distance in perceived signal strength versus the expected signal strength at various distances in a search grid. Locations with the lowest R-squared error rate were the most likely to be at the distance where the Wi-Fi hotspot was. We combined that with a Gaussian estimation. It creates a probability curve based on the likelihood that the Wi-Fi hotspot originated from a certain distance. It started with a negative inverted curve, which says that you're probably not standing right next to the hotspot while you're trying to find it. And then it added to that a regular standard distribution that was the probabilities at greater distances. The algorithm adjusted the width and height of those two curves as we collected more information. It created a heat map of probabilities for the signal source. So we normalized the probabilities for each location in that search grid, and the combination of those two probabilities gave us a much more accurate answer than either of them individually could. We stored the probability matrix of each location that a phone collected information for. Using these, we could collect readings where if you were walking in a straight line, we could tell you how far away the hotspot was. If you turned a corner, we could also give you the direction. And if you climbed some stairs, we could tell you where the hotspot was in three-dimensional space. The technology was the most interesting thing I'd ever built to that point. It's probably still the most technically interesting thing that I've ever built. But don't let that distract you. It was intended to kill people. I mentioned that I had a software engineering degree at this point. The rest of my team was less far along in their educational careers. Most of them were a year or two into a 4-year program, and they were computer science or math majors, where I was a software engineering major. Their expertise was in the mathematics or the theory of how processors work, as opposed to mine, which was in how to build software and design patterns and that type of thing. I helped to translate the working algorithms that they had built in MATLAB into the Java code that we needed to run on Android phones. And let's be honest, we spent plenty of time bike shedding, whether we preferred Eclipse or NetBeans. Can I just say that as a Ruby developer, I'm so happy not to have to know where to put a jar file, and I haven't had to know in 5 years. We also spent a lot of time bike shedding code organization or pairing on performance improvements to the code. It worked, but it took about 7 minutes to find Hotspot. This was partially because we translated the code from MATLAB, which is optimized for working on code in matrices. And the code that we initially wrote naively used nested loops. We're talking about quadruply nested loops here with some expensive calculations on the inside. One example calculation was that we were calculating the distance between 2 points. We were using great circle distance, which is how you measure distance between 2 points on a sphere, such as Earth. The function performing this calculation was being called hundreds of thousands of times each time the algorithm was run, often with the same 2 locations. It was a very slow process. We solved that by creating a hash where the keys were the 2 locations and the values were the distances between them. It was cheap memoization so that we didn't have to redo the same calculation for 2 points. That and other optimizations we made sped up the performance from 7 minutes to a few seconds. But don't get distracted by that. The performance made it faster to kill people. The accuracy of the locations wasn't fantastic either. I don't remember exactly what the accuracy error was, but an error of about 45 feet or 14 meters sticks in my head. That's about the length of a shipping container. And that's significant when the Wi-Fi range of 802.11n is only about 100 feet or 30 meters. It meant that we were off by up to half of the distance of the Wi-Fi hotspot. I talked about Gaussian estimation, 2 curves that made up the probabilities of the algorithm. We hard-coded the numbers that define the initial state of those 2 curves. They were starting points, and we changed those values, but they were starting points that we used each of those hundreds of thousands of times we were making this calculation. Does anyone know what a genetic algorithm is? I figured you might come in from Python. It's a type of machine learning that produces a set of values that are optimized for a desired result. Each of the Gaussian estimation values were a gene, and the set of values was a genome in genetic algorithm parlance. The genes were our 3 constants for those curves. A fitness function is what genetic algorithms use to measure the performance of a genome. For the data set of readings that I was using, I knew the actual location of the Wi-Fi hotspots that I was trying to find. And so I could run the algorithm against the data that I had and look at the distance between the actual and calculated values. A smaller distance was preferable, and that made the genome more fit. Genetic algorithms take a set of genomes called a generation, and they keep a certain percentage of top performers from the previous generation to survive. These top performers go on to the next generation as a copy. Sometimes the algorithm also mutates those copies as they're being made by adding a Gaussian random value to each value in the gene. This means that there was a chance that the copied values were slightly different and could perform better or worse than the previous ones had. New random genomes were created for the rest of the generation. And we saved the top performers across all generations so that we could say, this was the best one ever to have run. So I let that algorithm run over the weekend. It was able to increase the accuracy from 40-odd feet to about 10.3 feet, 25% the error that we had before. This was less than the GPS accuracy on the phones that we were using to collect the information. It's too accurate. It may have been over-optimized against the test data, which means that it wouldn't perform as well against actual real-world data. It's called overfitting when this happens, and it's solved by using separate sets of test and training data. But I didn't know that at the time, and I was super happy about the 10 feet error rate. I loved this stuff. Genetic algorithms, R-squared, Gaussian estimation. These are the type of things that you hear about in school, but you're never going to get to use. But we were using it in a real-world project. It was awesome. But don't get distracted by that. The software made it easier to kill people. The location algorithm now worked accurately and quickly. The next feature was to add tracking a moving Wi-Fi hotspot. I briefly wondered why a Wi-Fi hotspot would be moving, but that wasn't as interesting as finding a solution to finding where it was going. We made use of Kalman filters to observe 3 state variables: the position, velocity, and acceleration of the Wi-Fi nodes. Given that, and the time since the last estimation, the Kalman filter could create a surprisingly accurate estimation of where it would be in the future. So each time we ran the real-time algorithm, we would also feed the data into the Kalman filter. With only that information, it was able to produce an estimate that was a weighted average of all of the previous data, a new location that was more accurate than the calculated result. At the same time, we added the ability to track multiple Wi-Fi hotspots by differentiating between the SSIDs in the signals that we were collecting. We filtered the data sets by that SSID, and we were able to run the algorithm against every Wi-Fi hotspot in range, finding and tracking multiple hotspots in real time. We used the APIs on the phone to read the signal strength of the Wi-Fi access points. We were able to track multiple hotspots, basically whatever you can see when you're connecting to Wi-Fi, we could track down. It was all very exciting. They seemed like academic problems, but we were using them in a real project. Being a programmer was going to be great. But don't get distracted by that. This meant the software could be used to kill multiple people. We'd been working with a project owner throughout the process. He was hands-off about most things. He wanted to check in once a day, and then he would go back to his job in the classified area of the building, doing his real job. Whenever we hit one of these milestones, we would tell him about it. He'd be happy, but a question always came up. He wanted it to sniff out the signals put out by phones, in addition to those by Wi-Fi hotspots. This is a much harder problem from a technical perspective because it meant activating a setting on the wireless network controller known as promiscuous mode. Neither iPhone nor Android supported this feature out of the box, so we would have to either jailbreak or root the phones. We looked for packages that could help us do this, sniffing of packets sent back from phones to the Wi-Fi network. And the closest we ever found was a SourceForge project, but we didn't fully understand how it was used and it wasn't well documented. We told the project owner we'd come back to this later. We were making great progress on the Wi-Fi hotspot site locations, and that was the whole point, right? This other thing didn't seem important. Each time we would demonstrate a new and exciting step, though, he would come back to that same question. We got hotspots working. We located them. Great, does it find phones yet? It's taking seconds instead of minutes. Great, does it find phones? We looked into it finding phones, and it doesn't seem likely, but maybe? Okay, we can come back to that. We got moving targets working. Great. Does it find phones? I had been distracted. All this cool stuff that we were doing, all of these hard problems that we were solving, finding nodes, speeding things up, making more accurate predictions. It was so cool, so much fun. I hadn't thought about why we were putting all of this effort into finding a better place to sit and get good Wi-Fi on a cafe. Does it find phones? This was never about finding better Wi-Fi. It was always about finding phones. Phones attached to people. You remember I said I was working for the Department of Defense. The Department of Defense is the military in the United States. I was building a tool for the military to find people based on where their phones were and shoot them. I tried to rationalize it then. The military is in place to protect truth, justice, and the American way. But this is the same time that we were finding out that the government was spying on Americans in the United States using drones. They'd also lent out that technology to federal, state, and local government law enforcement agencies over 700 times to run their own missions. The military is a tool of the government, and it didn't seem like we could trust the government as much as we wanted to. I didn't want to be a part of building something that would be used to kill people, especially because I knew I would never know who it was used against, let alone have a say in how it was used. And I rationalize it now, too. We didn't have a clearance. The project this company did for the government were classified as top secret. We weren't allowed to know about them. The work that we did probably got shelved and forgotten about. Probably. This is an extreme example of code used in ways that the creators didn't intend. The project owner conveniently left out what it would be used for, and we conveniently didn't think too much about it. It was great pay for me at the time. It was a great project. Maybe I didn't want to know what it was going to be used for. I got distracted. I was distracted by the technology, but it would be just as easy to be distracted by a cool framework that a company was using or a design of an app that would look great in your portfolio. Some really nice office amenities or a huge paycheck. Other people are doing this, right? They must have thought about this stuff and it must be fine. No, that's another distraction. There are other examples of when code was used in ways that it wasn't intended, and of code that does bad things. A little over a year ago, a developer named Bill Sorer wrote a blog post. It opened with the line, "If you write code for a living, there's a chance that at some point in your career, someone will ask you to code something a little deceitful, if not outright unethical." Bill had been asked to create a quiz that would give a result that benefited his client. Bill worked in Canada, and in Canada there are laws about limiting how pharmaceutical companies can advertise prescription drugs to customers. Anyone can learn about the general symptoms that a drug addresses, but to learn specifics, you had to have a prescription. Because of this law, the quiz was posing as a general information site and not as an advertisement for a specific drug. If the user didn't answer in the quiz that either they were allergic to this drug or that they were already taking it, every result said that you should try out this drug. Go ask your doctor about this medicine. That's what the requirements said to do, and so that's what Bill coded up. The project manager for this project did a quick test before submitting the code to the customer. She said that it was broken. It always gave the same result. That's what the requirements said to do, Bill said. Oh, okay, she said. And they released that quiz. A little while later, Bill got an email from a colleague that contained a link to a news article. A young woman had taken the drug that Bill had built this software for, this quiz for. She had killed herself. It turns out that some of the main side effects of the drug were suicidal thoughts and severe depression. Nothing Bill did was illegal. Like me, Bill was a developer working at a company, his first job out of school, and he was just doing what he was told. He was keeping his head down. The purpose of the site was to push a particular product. That's what it was being made for. That's why they were paying him. He chalked the whole thing up to a marketing thing and did what he was told. He'd never intended for any of this to happen. Maybe Bill got distracted too. As his conclusion, Bill writes, as developers, we're often one of the last lines of defense against potentially dangerous and unethical practices. We're approaching a time where software will drive the car that takes your family to soccer practice. There's already AI programs that help doctors diagnose disease. It's not hard to imagine them recommending prescription drugs as well. The more software continues to take over every aspect of our lives, the more important it will be for us to take a stand and ensure that ethics are ever present in our code. Since that day, I always try and think twice about what my code will do before I write it, and I hope that you will too. It's poignant that almost all of those examples that Bill gave a year ago for things that we're approaching a time where this will happen are here today. Bill's story isn't that far off from mine, but there are others as well. Earlier last year, a story came out that Uber had built into its ride-sharing app code called Grayball. It's a feature of their violation of terms of service tool that allows them to populate their app with fake cars, with drivers when the app is opened by users in violation of Uber's term. In a statement, Uber said, "This program denies ride requests to users who are violating our terms of service. Whether that's people aiming to physically harm drivers, competitors looking to disrupt our operations, or opponents who collude with officials on secret stings meant to entrap drivers." In practice, as the New York Times reports, it's used in Portland to avoid code enforcement officers working to build a case against Uber operating without a license. It was, when triggered by Uber's logic, it populated the app with cars that didn't exist, with drivers that quickly canceled rides after accepting. I'm not a lawyer, but this seems like an obstruction of justice, itself a crime outside of Uber's unlawful dealings in Portland. Grayball is used even today, though mostly outside the United States. Now, I'm a huge fan of ride-sharing services. I took one to get here today. But it's not uncommon to see in the news these days articles about heinous things that these drivers are doing. Grayball may have enabled some of those things to happen. Again, it's an unintended consequence of a tool that was built. Maybe the internal pitch for this was to Grayball users who were violating the terms, like people who are under 18 or who had one too many explosive accident in the back of a car. Rather than block them, but probably causing them to just create a new account, they're just put into this alternate dimension where they can, for some reason, never find a ride. If these developers had thought about the worst possible case for how that code would be used, maybe an obstruction of an investigation or enabling these drivers to do terrible things would have come up, and that conversation could have addressed that ahead of time, and they could have changed what they were doing. There's all sorts of things as well that aren't as black and white as these. Apps that often or always listen to the microphone to tailor ads to based on what you're saying near your phone. Websites designed to exploit psychology and take up as much of your time as possible, which has been linked to skyrocketing depression rates. Any number of apps that sign you up for an email after you buy or sign up. Those aren't as obviously bad as the other stories that we've talked about, but they're still a little bit shady. This value system is different for other people as well. Richard Stallman, for example, believes that ebooks are unethical. Others may think that that's a little bit eccentric, but it is internally consistent with his other beliefs, and it's well-reasoned. There are actually words for the difference between what everyone agrees are bad versus what you or I individually believe. Ethics and morals. Ethics are imposed by an outside group, a society, a profession, a community like ours, a group of friends, or where you live. Religions provide ethical systems, and so do groups of friends. Societies in whatever form define right and wrong, good and bad, and they impose those distinctions on their members. Ethics in the local, state, and national level are often, but not always, encoded into laws by government. Morals, on the other hand, are a more personal version of the same thing. Society as a whole imposes their mores on its smaller communities, and all of that trickles down to the individual level. Now, that's not to say that your morals and ethics can't agree. For example, you might believe that freedom of speech is a fundamental human right, but you could live somewhere where defacing religious or political objects is considered wrong. But let's not get distracted by morals and ethics just yet. We'll come back to that. So the unifying factors in all the stories I've told is that developers wrote the code that did these unethical and immoral things. As a profession, we have a superpower. We can make computers do things. We build tools, and ultimately some responsibility for how they are used comes down to us. Not just what their intention is, but how they can be misused if they get into the wrong hands. None of us want to build the things that can be used for evil. The Association for Computing Machinery is a society designed to advance the computing as a science. ACM includes this in their code of ethics and professional conduct. Well-intended actions, including those that accomplish assigned duties, may lead to harm unexpectedly. In such an event, the responsible person is obligated to undo or mitigate the damage as much as possible. One way to avoid unintentional harm is to carefully consider potential impacts on all those affected by decisions made during design and implementation. So how can we carefully consider potential impacts? Honestly, I don't have the answer to this any more than anybody else does. I don't really think that there is a universal answer to this, because if there was, then I have to believe that we wouldn't be building this stuff in the first place. I do have a couple ideas. The first is to add to the planning process a step where we just think about what the worst possible use for whatever we're building is. Opting folks into an email list. Maybe the worst thing that happens is that we send them too many emails and they unsubscribe. Maybe they stop being a customer as well. As my friend said when we talked about this, am I willing to sell my hypothetical startup's soul for a few more email addresses? Especially when that might be all that keeps the company from going under? Yeah, no problem. And I get that. That makes a lot of sense to me. I don't think it's a best practice. I still think it's a little bit shady, but it's not physically hurting anyone. That's not that big of a deal. If I had to sit down and thought about what the Wi-Fi location app was doing, I might have come up with a very different conclusion. Actually, I think coming up with the worst possible way that software can be used could be a fun process. You might come up with some pretty wacky examples, like if we send Batman an email, and he happens to have notifications on his phone for new emails, then he might be looking at his phone when the Riddler drives by in the Riddler car. And he might not catch him before he gets his witty one-liner off at the crime scene. Riddle me this, riddle me that. Who's afraid of the big black bat? Now, that's not so plausible, but it shows that you can go down a lot of different roads that you might not come up with offhand without really thinking about this. Another thing I think that I should have done and that we can all do more of is to just not take that request at face value. The project owner at the defense contractor I worked at didn't spell out the reason for what the code was. But at least in retrospect, it's not a big leap of logic. We're going to build an app to find Wi-Fi signals is all true, but it's not the entire truth. Asking them or myself why enough times might have led me to an earlier understanding of what was happening. Why? To find the sources. Why? To go to them. Why? 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 Comedian Kumail Nanjiani, best known for the TV show Silicon Valley and his recent film The Big Sick, took to Twitter recently on this subject. I know there's a lot of scary stuff in the world right now, but this is something I've been thinking about and I can't get out of my head. As a cast member on a show about tech, our job entails visiting tech companies and conferences. We meet people eager to show off new tech. Often we'll see tech that's scary. I don't mean weapons, I mean altering video, tech that violates privacy, stuff with obvious ethical issues. And we bring up our concerns. We're realizing that zero consideration seems to be given to the ethical implications of tech. They don't even have a pat rehearsed answer. They're shocked at being asked, which means that nobody is asking these questions. We're not making it for that reason, but the way people choose to use it isn't our fault. Safeguards will develop. But tech is moving so fast. There's no way humanity or laws can keep up. We don't even know how to deal with open death threats online. Only can we do this, never should we do this. We've seen that same blasé attitude in how Twitter or Facebook deal with abuse and fake news. Tech has the capacity to destroy us. We see the negative effect of social media. No ethical consideration are going into the development of technologies. We can't put this stuff back in the box. Once it's out, and there are no guardians. It's terrifying. It's a major problem when we are given so much power in tech, but we're not doing anything to ensure that it's used safely. Thinking about what we're doing and being careful not to build things that can be used in evil ways is the least that we can be doing, and is really important. This is Chelsea Manning in an interview in the New Yorker Radio Hour discussing the ethics of what developers do.
Now, I guess technologists should, realize that we have an ethical obligation to make decisions that go beyond just meeting deadlines or creating a product. Let's actually take some chunks of time and say, wait, what are the consequences of this system? How can this be used? How can this be misused? Let's try to figure out, how we can mitigate a software system from being misused, or decide whether or not you want to implement it at all. There are systems that, if misused, can be very dangerous.
Don't get distracted by deadlines or feature requests. Think about the consequences of what you're building. Build in safeguards to prevent misuse. Or don't build it at all because it's too dangerous. I'm asking you to do something about this. Well, I guess I'm asking you not to do something because of this. So the least I can do is talk about when and where to take the stand. Let's say I have a time machine and I can go back in time to 2011 and I can do all of this over again. The tool has just been explained to me for the first time. What do I do? I think the first thing is to establish a mutual understanding between me and the project owner about what this task is. It's possible that at this point I don't understand what the thing is and I'm overreacting. I ask, why are we finding these signals? And the project owner says, to find people's cell phones. Who's finding them and why, I ask. I don't know, probably some soldiers in the Middle East. Why, I repeat. I can't tell you that. I can't tell you that is something I got a lot from this project owner. It's code for, I have a clearance and I know things about this project. I know what you're asking and I know the answer, but I'm not allowed to tell you. At this point, I think we have our mutual understanding. The task is to help soldiers find people's phones, probably attached to those people. The reason is left unsaid, but we all know what soldiers do. The organization is a defense contractor. They build things for the military. That's their core competency. They're not going to do this. On the other hand, I care a lot about not killing people. The company's goal is to build things for the military. The military is necessary, and sometimes they do need to use force. Personally, however, I don't want to be a part of that. If my goal is not to build these tools, then there's not a good fit for me at this company. That probably means that the worst case here is that I'm going to get fired, or I'm going to say, this isn't something I'm comfortable doing, but best of luck, and I'll quit. Those are worst case scenarios, not necessarily what will happen. So before saying no then, I need to consider, can I afford to leave here today without a job financially? Am I likely to be able to rely on my network to get me another job? How have I built up trust with my employer so that I can go to them with this type of thing and be heard out and not summarily let go because of it? The answer to all of these questions for me in 2011 was no. Sometimes something is important enough that you still have to do it. There's a lot that goes into these decisions, and they have consequences. I'd like to think that I would still say no. Let's take a look at another situation where somebody did the ethical thing. A developer we'll call Alice received a strange request. We want to identify weak passwords in the system to notify users to change them. We'd like you to run a password cracking program on this very, very large password database. Alice thought this was a weird request, but said if she got paperwork saying that she should do it, then she'll do it. Alice received the completed paperwork and she ran the crack. The next request was, we like that list of the user's emails along with their weak passwords. Alice knew that her coworkers had a valid desire to help customers fix their weak passwords, but she also knew that people tend to reuse credentials across sites. A report that contained both the email and the weak passwords would allow people to log in on other sites, not just this site. Alice pointed this out to her manager, and together they went to the customer support team, and they were able to design an email that didn't include the password, only the address that was being sent to. Customers received notifications about their weak passwords, and there was the risk of their accounts being hacked was lowered. No, not only was Alice not fired, but she actually built up trust in her network, in her team. Different scenarios need different ways of analyzing what you should do. In some cases, the right thing to do is to say nothing and build the product. It isn't a simple thing to make this decision. But don't get distracted by having to think about it. Sometimes your code can kill people. Thank you. So obviously I didn't have any slides, but